Okay, so before beginning, I would like to understand which is your knowledge about AWS services. Actually, this is Albert Capdevila. I'm from AWS. I'm a solutions architect, like Ruben. Are you more or less familiarized with AWS? For example, who knows what AWS S3 is? Okay, not bad. And what about AWS Sumerian? Okay, so you are not experts. Or what about the I think that the worst, by the way, it's a service that uses virtual reality to build worlds. What about, I think that the worst name that we have created for a service, it's CloudWatch Evidently. Somebody knows what it is? CloudWatch Evidently. Okay, so Peters are here, so happy to be here today. See you. Okay, CloudWatch Evidently, it's for implementing feature flags. Actually, somebody should explain me what's the relationship between evidently and feature flags. But okay. So you are more or less knowledgeable about AWS services. We're going to see some AWS services today. So please stop me if there is something that you do not understand, and we should go back to basics. Today we're going to talk about resiliency. Resiliency from a general point of view, but also in the AWS landscape. So you will hear me saying many times AWS. It's not for because of marketing. It's because we are talking about resiliency inside AWS, right? And when talking about resiliency, typically there are two words that should come into your mind. Two acronyms. Do you know which they are? Which one?
I'm not sure that's true. That's more like related to native systems. No, I don't know.
No. Which one? MTTS, not
TTF.
TTF. What does it stand for?
Time to TTR. Time to recover.
You're closer. You're getting closer. Okay. We're talking about RTO and RPO. The two acronyms that we should think about if somebody from the business tells us we need more resiliency. That does not mean anything. What do you need? Do you need your application keep on running if there is a meteorite that hits the earth? Or what do you really need? Actually, the question we need to do is, which is the maximum time you can deal with if we lose data? So the RPO, the recovery point objective, and which is the maximum time that the service can be down. So the RTO. And you need to ask that also thinking about the dimensions. So we need to know from the business or from the product owner, because at the end those are characteristics of a product or a service. We need to know the requirements, taking into consideration which risks we are facing. For example, the risk of a disk crashing in a server. Actually, in AWS, public cloud at the end, it's somebody else's computer. So there are computers. We really have servers. We really have disks, and disks break all the time. Actually, in words of our CTO, everything breaks all the time. So it's not the same the risk of losing a disk that the risk of having a meteorite hitting our country, right? So the RTO and RPO should also be linked to the different things that could happen, things that could go wrong. Typically, we're talking about application disruptions, something that it's quite easy, right? You are as SREs, so I guess you hate developers, probably. So developers tend to push code that doesn't work. That's an application failure, but that could hit our production environment. So that's something quite common. We should try to avoid. A disk crashing, it's also something common. Maybe it's not so common, but okay, it also may happen. But what happens is if a full data center falls down. We also have data centers. We have the concept of groups of data centers, which are called availability zones. We have many different availability zones inside the region, but something can happen. If a meteorite hits the region, everything stops working. So we need to balance, which is the RTO and RPO in all of those cases. So taking that into consideration, that's the first topic that we should know. When talking about resiliency, typically if you say which level of resiliency do you want with a product owner, it's going to answer you all the resiliency. So do not accept this kind of answers, go to the key points, the RTO and the RPO, depending on the risks that we are facing. So for that overview of the RTO of RPO of the applications deployed in AWS, we launched something like 1 year ago, a service that actually it's now, I see that it's now being used in many customers, just to have this vision. And this vision we trended to talk about resiliency, talking about technological pieces. So many times horizontal pieces, for example, a database. Which is the RTO and the RPO of a database? It doesn't matter to a product owner. The product owner needs to have the whole vision of the whole application. It doesn't matter to him if it's the database what has failed or it's just the internet connectivity between a node. It doesn't matter. So the RTO and the RPO, we need to have somewhere the visibility of the RTO and RPO of our applications, not of our technological components. We have plenty of solutions, APM solutions, you state, for example, observability tools. We already have those tools to look at this from a technical point of sight, but we typically do not have them from a more functional point of view. I'm going to show you a demo of the service that we launched. It's called AWS Resiliency Hub, that actually is for that. And I think it's quite interesting because it mixes two topics. The first one is the overview for the product owners or the service owners about those metrics, but it also it's linked with chaos engineering. How many of you know what chaos engineering is? No, some of you don't. Probably you know the story of Netflix having a chaos monkey. Chaos monkey, it's some pieces of software that really crash things in the production environment. So while you are looking a film in Netflix, there is some software that is throwing things down. Okay, I'm going to kill a server. I'm going to kill a disk. Why? Because they also consider that everything could fail during all the times. And if they introduce failures in their production environment, they ensure that the engineers design the applications so they are tolerant to this kind of failures. That's the principle under the chaos engineering methodology. Nowadays, we have a service in AWS which is called Fault Injector Simulator that permits you to simulate errors. You know, typically when somebody is thinking about which tests we should include in our CI/CD pipelines and so on, typically it's difficult to build them. Because at the end, there are things like, okay, how can I simulate that a disk is crashing? How can I simulate that the whole data center is falling down? It's something quite difficult, right? And it's something very difficult to automate. Maybe we can simulate that with in AWS. At the end, it's a cloud service, so everything is at one click from being done. So I can go and just stop a server. Or I can go and just detach a disk, no? But it cannot be automated. So we launched Fault Injector Simulator, which is a service that permits you to introduce the API calls that simulate these kind of failures. By the way, they simulate it because really the disk is not failing. But for your application, the disk is failing. So don't try to be Netflix at the day zero. First of all, try it in the development environments, and once you are mature enough, then you can think about doing that in production. But the failures are real. So this service, Resiliency Hub, sorry, I'm tired today, is really mixing the two views that I told you. The first thing you would like to have is a tool where you can see which is your resiliency level from an application point of view. So having things like, okay, which applications I have in policy, so they are in the RTO and RPO objectives that I have defined. And based on that, I can just scroll down. So I already have an application here. So everything now it's in compliance, which is called the Web 3 Tiers application. And here I can see the resiliency score. We'll talk about that in the future. Which alarms I have configured linked to that application, and also which experiments of chaos engineering I have executed. That should be more or less the goal. Now let's see how we can build this kind of dashboard and which additional tools are offered under this service. So the first thing I'm going to do is I'm going to register a new policy. A policy is an RTO and RPO goal. So here we can define a new one. We can define it from scratch, or we can based it on some specific templates. Let's define it with a template. So a mic and the mouse, it's quite a challenging scenario. Huh? So here we have some suggestions. For example, non-critical application. That means that we want to have this kind of RTO and RPO. 2 days of RTO, 1 day of RPO. That's clearly a development environment. It's not a production environment. And the RTO and RPO related with different dimensions, as I said. The application dimensions, so the code. If a ransomware hits us, what happens? So that's one of the incidents that we might have that might affect these metrics. From a cloud infrastructure point of view, and in that case, a cloud infrastructure failure could be different things, right? And they are not seamlessly to happen. So it could be that a disk has failed, so an infrastructure incident, that a whole data center or a whole set of data centers has failed, so an availability zone failure, or that a whole region has failed. So imagine there is a war and the government stops the connectivity with the region in Ireland. That could affect the whole region. We always say in AWS that an availability zone is the maximum unit that can fail at a single time, because they are redundant, they are absolutely independent one from another, but at the end there are other dependencies. So all the availability zones in a region depend of a single country. So what happens if the government says that we need to cut the connectivity? So at the end, if we need a solution that is 100% reliable, okay, no, close to 100%. 100% means 100% of resources that you need to invest, because if the Earth disappears, you need a data center in the moon. So, but if we want to get closer to 100%, we also would need to consider to have another region, another AWS region where we could fall back. So here we would define the policies, and we could have different tiers for the application. The typical tier 1 application, tier 2, tier 3. Once we have the policy, we can register the application. And registering a new application can be done from different ways. Maybe you have it in Kubernetes, which is EKS, our Kubernetes managed service, or we might have it with infrastructure as code, so with Terraform stacks or with CloudFormation stacks. So we could directly import the infrastructure as code and say, this CloudFormation, that's an application. All the resources defined in this CloudFormation are part of a single application. Or we could also have other strategies, like for example, tagging them in AWS. So if we create a resource group, so it's are tags specific, we group different resources in AWS into a single application. I will show you, for example, the CloudFormation option. So I have different CloudFormations here. I think is if I'm not wrong, this one works. Otherwise, I'm going to say that that's the typical demo crash that it's happening. Yeah. This check was not there yesterday. That's why you shouldn't do things in the console. You should do that with the API. Okay, right now, he's analyzing the CloudFormation stack, and it's going to tell me which resources have found. So he has found some kind of NAT gateways, load balancers, an auto-scaling group for instances for compute. We have some S3 buckets. At the end, we have this kind of architecture, Okay? So we have the front end static in S3. We have an application load balancer that balances the load to different servers under an auto-scaling group. So they are auto-scaled depending on the traffic, and we have a managed database with a primary and a secondary node. Each of them in a different availability zone. So that's more or less what I have showed you. Just with that, if we say next, then we need to assign which policy this application should there too. So let's say that this is an important application. That means this kind of RTO and RPO. And once we click in publish, he's going to do an assess. What he's going to do right now, that's something that takes 1 or 2 minutes. It's going to analyze the structure of the application. It's going to group the different components in a best effort. For example, you saw that there were 2 NAT gateways. Maybe the 2 NAT gateways are part of a single component or not. Imagine that you have different servers. Maybe your application logic is spread through all the servers, but maybe they should be grouped somehow. Maybe you have 4 servers with some layer of your application, 4 additional servers with another layer of the application. So they should be grouped in 4 and 4 to think about the resiliency that the application has. In Kubernetes, typically you will have the different pods and they should be distributed in different servers, right? So he's going to apply the best effort to group the components. If the tool is not okay, then you can go and regroup them. So that's something that you can always do. You should configure the structure of your application in components. You see, for example, that here we have those components, and there is a component that has 2 resources. So he has already grouped the 2 NAT gateways into a single resource. So he's going to consider that if one of them fails, the other one is the failover one. And once done that, I'm going to show you some executions, some assessment that I previously did with this same application. So here you can configure, for example, that the assessment is executed, I don't know, every week, for example, to ensure that nothing has broken. And with those assessments, for example, I'm going to show you this one that breaches the policy. And here we have the results. And we're going to have the explanation of why the policy is breached in any of the metrics and dimensions that we have defined. For example, the application, it's irrecoverable. He has found that the database has no replica or neither backups configured. So if there is a ransomware that encrypts our database, you are not going to be able to recover that. You should configure the backup for the database. For example, the S3 bucket, something similar. You don't have a recovery point for the S3 bucket. You don't have version enabled or replication activated. So from an application point of view, you have an RTO that it's infinite because it cannot be recovered. Some other components are really in the right metrics. Those metrics are typically based on estimations that we have. So for example, the time to recover a database, if you have a replica, we have some metrics that stands depending on the size of the database, how much time it usually takes. So we are working with this kind of estimations to calculate those numbers. And the same for the infrastructure, for the failure of an availability zone. For example, it seems that everything is into availability zones, but in this case, there was a single NAT gateway the first time I executed that, so it stands that there is no recovery point. Then I added the second one. That's why there are other assessments that are meeting the metrics. So you have this kind of analysis, and you have also the recommendations. So what should I do to really cover the objectives that I have stated? So for example, for the database, I have 2 options. One optimized for cost, and the other one optimized for availability. So to minimize even more the RTO and RPO. If I just want to optimize for cost, if I simply enable the backup of the database, then I'm going to be on the RTO and RPO scenarios that I defined. And it's going to cost me nothing. So please do that. You have another option. In that case, we could switch from RDS to Aurora implementation, which is our own implementation that makes independent the compute from the storage. So typically it recovers faster if there is a failure. In that case, it's going to cost you those dollars every month, but then your RTO and RPO will be less than in the previous case. So you have this kind of recommendations to just keep with the goals that you defined. And we have also additional recommendations, for example, operational ones. Here, now let's focus on not only assess if your application is resilient enough, but also ensure that you have the methodology to make it up and running and again if something happens. So we are now moving to the active part, not the passive and auditing part that is covered by the metrics. So here, automatically, he tells you, you should configure this kind of alarms in CloudWatch. So to detect if the CPU is too high, to detect if the database is failing. So you need to have these alarms configured. And you could just say, okay, I agree, but only those ones. So these 3 alarms, please create me the CloudFormation template. So the infrastructure as code that I can just deploy in my environment to create those alarms. I'm proposed to implement standard operating procedures. So for example, the procedure to fall back a database to a secondary one, or a procedure to increase the auto-scaling group capacity if there is too many traffic entering my cluster. These kind of operating procedures can be on a wiki or can be really automated. There is a service in AWS which is called System Managers Automations that permits you to just define those scripts and launch them when you want, based on the value of an alarm or based on a click of somebody. You know, the difference between CI and CD, something similar. So in that case, you can also say, okay, I agree. Those 2, create the CloudFormation template, and I'm going to deploy it. I'm not going to deploy it here because I have a CI/CD tool to deploy CloudFormation stakes, because everything is automated. And it also proposed you the creation of chaos engineering tests. So you already are proposed to automatically create those kind of fault injector simulator experiments to simulate the incidents according to the structure of your application. So for example, let's see some of them. For example, if multiple availability zones fail, let's see if the application is able to recover. So if we create this template and we launched it, we will launch to the application the signal that 2 availability zones are not available. And let's see if they are recovering or not. For example, load test. A load test regarding CPU or regarding memory. For example, simulate an auto-scaling group failure in an availability zone. Simulating that there are RDS instance so the database reboots. And we can also say, okay, so let's create this stuff. Some of those templates need additional configuration because typically are based on an alarm that was defined in the previous template. So here you need to specify which alarm it refers to. So in that case, because it's already 8 p.m., I'm going to create that without requirements. And I'm going to have here all the templates that I have defined. You could just deploy them and you have been able to prove that your application is resilient enough. So you could run the tests and you could measure that the estimation that we did, for example, for a database failure recovery, that was, I don't know if it was 5 minutes, that it's really 5 minutes. So you can launch really the experiment and say, okay, in my case, I have some stored procedures that are launched when the database is going out, so it's not 5 minutes, it's 10 minutes. And with all this data, we built the application scoring regarding resiliency. If all the RTO and RPOs are okay, we will have a 40 here in the resiliency score. To reach the 100%, we need to deploy all the alarms or the standard operating procedures, and we need to deploy and run all the experiments. All this information is also going to be linked here. So we will see the alarms that were configured, the experiments that have been launched, and we have this kind of holistic view regarding the resiliency for a single application. So I know we are already out of time, so it's 8 p.m. I don't want to go more in deep with that. We could be talking about that for 2 hours. But if we would like to play a little with that, I just recommend you. Okay, I think I was presenting the PPT. Here you have a couple of interesting workshops that you can launch. By the way, this service, you can use it for free for 3 applications during 6 months. So the free tier permits you to play around for free. And these are two workshops that you could try if you would like. The first one, it's focusing on Resiliency Hub. The second one is focusing on Fault Injector Simulator, which is the service that only deals with the chaos engineering part. For example, if there is here somebody running a Kubernetes cluster in AWS, Kubernetes everywhere. Somebody running ECS in AWS? Okay. Kubernetes, it's quite complex for me. Okay, so are you using a spot in Kubernetes? Yep. Everybody knows what a spot is, and I promise you that I'm going to shut up after that. Spot, it's a way of using the spare capacity that we have, paying something like a 70 up to 90% of the price, in the price reduction, not the price. So you pay a 10 or 20% of the full price, but it's a spare capacity. That means that we can, if we need it, we're going to pick it up. You have 2 minutes to give the capacity to us. If you don't give it to us, well, not to us, to another customer which wants to pay the 100%. If you don't send it to us, we are going to pick it up. So we send you an interruption signal that in 2 minutes we are going to throw a server. That's something that I would never suggest to run an SAP system in this kind of technology. But if you already are in Kubernetes and you have designed your applications so they are fault tolerant to a failure, you can really run your workloads in a really cheaper way. What happens? That there is no way for you to simulate an interruption signal of a spot. So you always are uncertain that, okay, I'm playing with a spot, but at some point, some instant it's going to fall down. And it's not going to fall down in a natural way, that it will receive an interruption from AWS, that I have read it in the documentation, that with this configuration, nothing is going to happen, but I want to see it working. And you are not able to see it working. There is no way you can simulate this kind of signal. With Fault Injector Simulator, you can simulate that. So you can send a spot interruption. So for all of you that are running EKS, I highly suggest you to consider using a spot, and I highly suggest you to consider using Fault Injector Simulator to check really when you want, not when it happens magically, when you want that there is an interruption and that your application is not affected for that. And that's all.